A mechanic applies a force of 200 Newton to the end of the spanner here by hanging a mass M as shown in this diagram here. So the force that is applied is the gravitational force, and we can also say that is the weight of the mass. That will be 200 Newton. And given the gravitational field strength as 10 Newton per kg, we can find the mass of M. By using the formula, W is equal to mg. So M is just the weight divided by the gravitational field strength. That will be 200 divided by 10. We will get 20 kg. Okay, we have a cube with size of 2 cm and the density is 8 gram per cm cube. So if you want to find the mass, right, we can just use the formula. The mass is equal to the density multiplied by the volume. So we have the density as 8 gram per cm cube multiplied by the volume. Volume of a cuboid will be length times breadth times height. So we will have 2 cube. That will be 8 times 8, 64 gram. Answer D. Okay, this is a principle of moment question. So we have a wheelbarrow here. We can see that the pivot is at this point at the center of the wheel, and we have two forces. The first force is the weight of the wheelbarrow and its load, and it's pointing downwards, and this will create a clockwise moment about this pivot, and the perpendicular distance between the force and the pivot, it is 0.75 meter. And the second force is this vertical force applied at the end of the handles. So this force is going to create an anti-clockwise moment about this pivot, and the perpendicular distance, it is 0.75 plus 0.75 meters. That will give us 1.5 meter. Okay, so now we can use the principle of moment equations. Clockwise moments is equal to anti-clockwise moments. So we have 150 times 0.75 is equal to F times 1.5, and F is equal to 150 times 0.75 divided by 1.5. That will give us 75 Newton. Answer A. We have a man walking on a tightrope carrying a long pole. So the question here is, why does he carry the pole? Okay, the answer is A. It's to make it easy for him to keep his center of gravity above the rope. In order for the man to balance himself, right, his weight must cut through the rope directly, such that it does not generate any resultant moment to topple him. So carrying the pole, right, allows him to adjust his center of gravity by shifting the pole left and right, such that his center of gravity is always directly over the rope. Okay, now let's look at the other three options. Okay, option B, if his center of gravity is raised, it makes him more unstable and more likely to topple, so it cannot be the answer. To reduce his pressure on the rope, okay, so we have to understand that the pressure formula is pressure is equal to force over area, and carrying the pole will increase his gravitational force, which is the combined weight of himself and the pole. So if the force increase, the pressure will increase instead of reduce. Okay, so this is not the answer as well. And carrying the pole does not spread out his weight. His weight should still act at the center of his body, which is the which is the center of gravity, so it does not spread out. This is wrong as well. So the answer is A. This is a recall question. When we multiply the magnitude of a force by the distance moved in the direction of the force, we are actually doing force times distance in the same direction. This is the formula for work done. So the answer is D.